We are going to be going through the 7-2 guided practice problems. So first, on all of these problems up at the top, you need to make sure that you know how to show the work for this without your calculator. So we're not going to stop you from checking yourself with your calculator, but you need to be able to show the appropriate work. So whenever we have a problem like this, 216 to the 2/3 power, we want to break it down into the root power and then the other power. So remember that square roots are the same as taking something to the 1/2 power, so power divided by the index of the radical, and then cube roots are the same as taking something to the 1/3 power, fourth roots to the 1/4 power, etc. So all of my root powers are these fractional ones. So when you're trying to split it into the root power and the other power, we want to hone in on this denominator. So we see that we have a denominator of 3. So we are going to kind of twist apart that power and make it 216 to the 1/3 raised to the second power. Now going back to our exponent rules from Unit 5, when we have a power like this, we would multiply those together. So what's 1/3 times 2? It gives me 2/3. So I'm not changing the value of the expression. I am just rewriting it. And by rewriting it this way, we can then take 216 and the cube root of it. So using our little pink sheets, if we look in our cubes column, we see that 216 is a perfect cube, and thus the cube root of it would be 6. So that allows me to simplify what's inside the parenthesis, and from there, we can obviously simplify 6 squared into 36. So notice that when we twist apart the powers, we want to put the root power on the inside, because if we try to do it the other way, we'd have 216 squared and then to the 1/3 power of the cube root of it. Do you want to take 216 squared without your calculator? No, bad time. And also that would probably give you a number so big you might not even be able to find the perfect cube on your cube sheet. So when you are breaking down the power, you always want to do the root power first to break down your number into something smaller, and then take the numerator power on the outside. So this is no good. So taking a look at the next one, the only difference here is we have a negative exponent. So we're going to do the same thing that we did on this problem. We're going to break it down into our root power. And what is our root power on this one? The 4. So the dividing by 4, we can make to the 1/4 power. And then there's a few different ways that you can handle that negative exponent. So remember, negative powers, change your base and send it to the downstairs of the fraction. So send it to the denominator. So what I normally do is I will break this down into the cube power and then the -1 power. If you're comfortable doing it to the -3rd power, that's okay, but sometimes I like to wait for kind of the fractional aspect of it or flipping it to the denominator until the very end. So from here, we've split it into the 4th power, the 3rd power, and the -1 power, and if I multiplied all those together, we would still get the same -3/4 that we started with. So by breaking up the power this way, because again, just straight up taking 81 to the -3/4 without your calculator, it's like, what does that even mean? But when we break it down into the root power, the 4th root of 81, then cubed, and then to the -1. So now we can go to our pink sheet, and we see that 81 is indeed a perfect 4th, and the 4th root of it would be 3. So then this turns into a 3. Then I'm raising that to the 3rd, and that to the -1. So 3 to the 3rd, 3 times 3 times 3 would give us 27. And what's 27 to the -1? 1 over 27. So remember, those negative exponents don't affect the sign of the number. They change its position within the fraction. Ta-da! So again, folks, there's a few different ways you could show it if you wanted to just take that to the negative third and say, I know that's going to turn into 1 over 3 to the third. You can do it that way as well. That will also give you the 1 over 27 for your final answer. But you need to be very explicit with showing the work of breaking it down into the root power, and that we know that that is the same as taking the cube root of it. So that's the type of work that I want to see on those green formatives that you guys are doing. That's the kind of work we're going to be looking for on the test. It has to be very clear that you did it or were able to do it all without using our calculators. Okay? Any questions on those two? Alrighty then, moving on to number 3. Again, we're kind of back in our power realm again. So when we are powering up, just like I said here, we can multiply those exponents together. Now, if I have x to the 4/5 raised to the power of 2, sometimes students will try to multiply the 4 and the 5 by 2. So what I like to do on a problem like this, because we just did all those lovely fraction rules in our last chapter, is I like to put the 2 over 1. So then when I power up, I multiply those fractions. And how do we multiply fractions? We go straight across. And that would give me 8, and then 5, and then my base of x. Another common mistake that students will make on these is they'll just get so hung up on the fractions that they'll forget to write the base. So make sure when you're applying those power rules that you don't forget the original base x. So that brings us to number 4. Here, going back to Unit 5, how do we handle dividing the bases? And folks, if you can't remember, forget the fractions and turn it into an easier problem. What would I do if I had x to the 5th over x squared? Does anyone remember what we do with the exponents? We subtract them. And folks, even if you couldn't remember that, you can always do a full expansion. X times itself 5 times, x times itself 2 times, and you can see that those x's cancel, leaving you with x cubed. So if you forget a rule or something that you've had to have memorized, it never hurts to try to put it in terms of something easier like non-fraction stuff to help you recall the rule. Good strategy for the ACT as well. So folks, from here we can see that we are going to subtract these exponents. So I am going to need to subtract those two fractions. So I'll have x to the 3/4 minus 2/5. Now thinking back to our last unit, what do we need to subtract those two fractions? Got to have a common denominator. So common denominator of 4 and 5. I'm going to have to multiply this one by 5 over 5 is the creative form of 1. This one I'll need to multiply by 4 over 4. And again, don't forget that negative in between those fractions. We will end up getting 15/20. So x to the 15/20, and then minus 8/20, and that will give me x to the 7/20. And same rules as before, always make sure you're simplifying your fractions. So like if we got x to the 5/20, you would want to simplify to be x to the 1/4. But you wouldn't have to change it to like a 4th root or anything. If it's written in exponential form, keep it in exponential form. So that would be x to the 7/20. Questions on those two with the power rules? Alrighty then, for the very last problem, we are going to be writing this in exponential form. So folks, if you can remember these relationships, this kind of gives you the key from going from radical form to exponential form. We always take the power of the item under the square root divided by the index of the radical. So index. Also, if you didn't take the 7.1 formative yesterday, a really common error that we see both on those and on the test is forgetting to write the index with your final answer. So some of you guys probably got those back already. So the index is huge. So I'm always telling my students, don't forget the index. Don't forget the index, because if you don't include the index, then it's just going to be assumed to be a square root. So to go from radical form to exponential form, we take the power of the base divided by the index. So power divided by index. So here we are just rewriting. We don't have to worry about simplifying it all. So even if this was like x to the 9th or something, where I could break it up and try to simplify that a little bit, here we are just rewriting. We're not simplifying. So when I go to simplify to rewrite the 25 in exponential form, currently, what is the power of that 25? It's 1. Coefficients have an implied power of 1. So when I take that power divided by the index, we get 25 to the 1/4 power. Then I do the same under the radical. Power of 2 divided by the index of 4, so x to the 2/4. Power of 3 divided by the index of 4, we get y to the 3/4. Now, which of these fractions doesn't look the best, or what could we do with it? Simplify that 2/4 to be 1/2. So our best answer would be 25 to the 1/4, x to the 1/2, simplifying that fraction, and y to the 3/4. And that's as far as we go when we are rewriting. Power of the base under the radical divided by the index of the radical. And that concludes the 7.2 guided practice problems.